Assalamualaikum, my name is Nurani Sliana and I will present about introduction to the device. A new semiconductor material, gallium nitride, provides a potential solution to the lighting problem. Unlike silicon, gallium nitride emits brilliant light when a small electric current is passed through it. Gallium nitride is used to make white light-emitting diode. These solid-state light sources are already much more efficient than conventional tungsten filament light bulb and could potentially yield efficiency improvements of more than 10 times and also can be 3 times more efficient than compact fluorescent lamps. By adding more and more indium gallium nitride, we can produce light of any color, for example, blue, green, yellow, red. Gallium nitride LEDs are based on thin layers of material grown on other materials such as silicon or sapphire. Electric current is passed into the active region of the LED from which the light is emitted. The active region consists of very thin alternating layers of gallium nitride and another semiconductor such as indium gallium nitride. The indium gallium nitride layers are only 10 atomic layers thick and are called quantum wells. In the indium gallium nitride layers, positive and negative charge carriers become trapped and hence combine with one another, giving out light. On the other hand, if we add aluminium to gallium nitride, we can produce ultraviolet light. Gallium nitride-based light-emitting diodes and laser diodes are already in widespread use, for example as LED traffic light and as Blu-ray laser diodes. Gallium nitride produces light so efficiently that if we could use white gallium nitride-based LEDs for home and office lighting, we could save 15% of all electricity use and also reduce carbon emissions from power stations.
Assalamualaikum warahmatullahi wabarakatuh and hi. I am Nurul Amira binti Osman and I'm going to present about the manufacturers related to the device. These are the top 6 vendors in the global gallium nitride devices market from 2016 to 2020. The first one is Avago Technologies, the second one is Cree, third is Gallium Nitride Systems, fourth is Infineon Technologies, the fifth one is Osram Opto Semiconductors, and the last one is Qorvo. Fortunately, among all, 5 branches are located in Malaysia. We have Avago Technologies and Cree in Penang, Infineon Technologies in Melaka, Ipoh and Kulim, Osram Opto Semiconductors in Penang, and Qorvo in Ipoh. Avago Technologies manufactures analog semiconductor devices. The company's product offerings cater to the industrial and automotive electronics and so many more. Cree is a manufacturer of semiconductor LED materials and devices. Cree follows a growth strategy that integrates the perspective of sustainability. Gallium Nitride Systems is a manufacturer of gallium nitride high-power switching transistors and diodes. Infineon Technologies develops, manufactures, and markets a wide range of semiconductor products for the communications, automotive, and memory markets. Osram Opto Semiconductors has diversified its portfolio to provide a wide range of lighting applications such as high brightness and high power LEDs. Qorvo is a company that provides core technologies and radio frequency solutions for mobile, infrastructure and aerospace and defense applications.
My name is Zuriati binti Zakaria with method number 139321. So I will explain about fabrication process of gallium nitride LEDs. Firstly, the semiconductor wafer is made. The crystalline semiconductor is grown in a high temperature, high pressure chamber. The gallium are purified and mixed together in the chamber. Then the heat and pressure liquefy and press the components together so that they are forced into a solution. After the elements are mixed in a uniform solution, a rod is dipped into the solution and pulled out slowly. The solution cools and crystallizes on the end of the rod as it is lifted out of the chamber, forming a long cylindrical crystal ingot or bowl. Next, the ingot is then sliced into very thin wafers of semiconductor, approximately 10 mil thick or about as thick as a garbage bag. The wafers are polished until the surface are very smooth, so that they will really accept more layers of semiconductor on their surface. Each wafer should be a single crystal of material of uniform composition. Next, the wafers are cleaned through a rigorous chemical and ultrasonic process using various solvents. Process remove dirt, dust, or organic matter that may have settled on the polished wafer surface. Additional layers of semiconductor crystal are grown on the surface of the wafer. This is one way to add impurities or dopants to the crystal. The crystal layers are grown this time by a process called liquid phase epitaxy, LPE. The wafer rests on a graphite slide, which is pushed through a channel under a container holding the molten liquid. The deposited layers will become a continuation of the wafer's crystal structure. After depositing epitaxial layers, it may be necessary to add additional dopants to alter the characteristics of the diode for color or efficiency. If additional doping is done, the wafer is again placed in a high temperature furnace tube where it is immersed in a gaseous atmosphere containing the dopants.
I'm Yushin, so I'm going to continue our group presentation on the fabrication process of gallium nitride LEDs. So as we actually stopped apart on the epitaxial layers, I'm going to continue from here. So after the epitaxial layer is deposited, the wafer are then undergoes the photolithography process, which etch the wafer into the pattern as shown in figure. The reason of this photolithography process is done is because we want the N-type gallium nitride is exposed and ready to form an N-type omic contact. So after the etching process is done, a semi-transparent metal omic contact layer will be deposited on top of the P-type gallium nitride, which can improve the hole's current spread. So these layers are usually made up of nickel and gold layer, both of 5 nanometer, and deposited consequently on top of the P-type gallium nitride. And after the semi-transparent layer has been successfully deposited on top of the P-type gallium nitride, the process is then continue with the deposition of electrode on top of the semi-transparent layer and also on top of the N-type gallium nitride. On the top of the semi-transparent layer, the metal deposited is a gold layer with 200 nanometer, while on top of the N-type gallium nitride, 100 nanometer of gold layer are deposited. After both this deposition process is done, the wafers are then annealed at a high temperature and a long time. So this is because it wants to make sure the metal and the semiconductor are bound together chemically, so the contacts don't flag off. After the wafers are annealed, a single wafer is produced with the same pattern, and these wafers are then cut into small segments either by solving with a diamond saw or by cleaving. And each small segment of this, or we call it as a die, are mounted on the appropriate package. So in terms of the LED package, a tiny gold wire is soldered to the other lead and wire bonded to the pattern contacts on the surface of the die. And after this process is done, the entire assembly are sealed in plastic, and the wires and die are suspended inside a mold that is shaped according to the optical requirement of the package. And the mold is filled with liquid plastic or epoxy. The epoxy is cured and the package is complete. So this marks the end of the fabrication process of the gallium nitride LEDs.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syairah binti Mat Salim. I will continue for my group in the presentation in application of gallium nitride LEDs. Application is we can see at the traffic signal, outnode signage, automatic head interior lamps, LCD for mobile phone, TVs, and the laptop. And then also the application is the general lighting, as we can see in the industrial, street lighting in household. And then for the traffic signal, LEDs are much more suitable than light bulb because much lower energy consumption, long lifetime, better high quality. And then for outdoor signal, as we can see more in the shopping mall, LEDs consume less energy, live much longer, don't show flaky when aging, can be controlled to show images and more flexibility. In the automotive light, we have the intelligent lighting, where the color composition corresponds to external lighting condition. Why gallium nitride LEDs have been chosen? So the first thing is the main light emitting semiconductor. As we can see at the chart, the wavelength for gallium nitride LEDs from the 350 nanometer to 800 nanometer and have several colors. Uh, we can we can use in the application. So the potential of gallium nitride also lighting uses 1/5 of all electricity and save 10% of all electricity. And the left is the we can see at the Perman Street, Las Vegas. The now we use 12.5 million LED. It's more than latest use filament bulb, only 2.5 million.